Hello everyone, we are final year students from the FinTech major. Today, we are delighted to share with you the accomplishment of our FYP project, measuring and improving readability in insurance and health documentation. I believe that most of you have experience in purchasing an insurance product. Traditional insurers usually rely heavily on agents to communicate with customers in order that they understand their needs and clearly explain complex documents and contents, for example, terms and conditions and disclaimers. With the rapid growth of virtual insurance companies, it is unlikely that an agent is present. They emphasize on creating blogs, product specification and brochures, terms and conditions on their websites to assist customers' decision-making. Yet, it is noticed that misconceptions arise as the terms and conditions are too hard for the customers to read alone, making the customer fail to capture the true implication of the terms and conditions. Under these circumstances, two major problems were spotted: negative influence on customers' experience as well as the reduction of companies' efficiency in checking insurance documents manually. Readability analysis, therefore, plays an important part. It is crucial to measure and improve the readability of documents in an automated way. With the definition shown below, it would be desirable for readers to follow and understand a piece of document with less effort. We define three objectives: identifying underlying problems, develop a readability model, and conduct automation. We have put emphasis on the readability analysis of Chinese terms and conditions in this project. We believe that Chinese readability analysis could significantly benefit the insurance industry, especially when there is a lack of Chinese readability research. Previous work usually focuses on analysis of articles or web contents. Also, the Chinese readability test models for business document is not well developed. We hope to be the pioneers for developing Chinese insurance readability model. Moreover, insurance and health documents are commonly laden with jargon. As mentioned earlier, the ease for customers to follow a document is of vital importance when it comes to his or her decision-making process and overall experience. In companies' perspective, it is essential to ensure a scientific and automatic readability analysis and improvement process. Let's take a look at the main feature of our model. It can be presented in three aspects: process automation, data visualization, and readability improvement suggestions. The UML activity diagram here shows the system workflow. The master file manages the whole process flow. If we want to measure the readability, the program runs through the model pre-processing, scoring, visualization, and suggestion one by one. The final output would be a set of HTML files. If we want to refine the model again, it will run through the workflow on the right-hand side, pre-processing and regression. In the regression model, it is automated such that user can execute the data training process without prior knowledge of machine learning. A final readability formula and a readability score from 0 to 5 will be derived for each corpus as our final output. The higher the score, the higher the readability. Apart from the quantitative result we have obtained, we also identify and visualize trends and patterns using graphs. We plot the readability score in a histogram. To compare the performance, we also roughly classify score into different classes by setting some threshold using standard deviation as shown below. Line graphs were used to compare the performance of each variable in each corpus with the mean, upper quartile, and lower quartile of the whole set of data. This example includes variables that negatively affecting readability. The smaller these variables contributes, the higher the readability score. We can then select the potential problematic variables that contributes to a low score to assist further readability improvement. Finally, readability improvement is suggested for each corpus. Take phrase and sentence length as example. They are indicated at the end of each phrase and sentences. They are categorized into 4 different levels according to its frequency in proportion to the whole set of corpora. Now, let us take a closer look of the demo of the system. User can select between 3 actions in the beginning: measure readability, retrain model, and exit. The first major function is measuring the readability. We store all the corpora we want to measure into the folder corpus. To make the demo simpler, we are analyzing one corpus as an example today, which is 01 premium. We then input number 1 to start measuring the readability. After processing, we can find the readability test report in the HTML file here. Results are shown clearly in the report. It includes the name of the corpus, date created, corresponding readability score, score statistic of all the corpus using in the training model, line graphs, suggestion for the corpus, as well as the detailed feature statistics, namely average, median, and standard deviation of the features. In particular, line graph 1 is a line graph that indicates variables that positively influence the readability. The higher these variables contributes, the higher the score. As for line graph 2, it visualizes the variables that negatively influence the readability. When it comes to suggestion, we use HTML file to indicate the performance of individual corpus in details. As you can see, we listed out the improvement suggestion for different features here. Let me now show you another function, which is automated model training. To retrain the model, we need a training dataset, which is the collected readability score for each corpus. Likewise, we store all the corpora for retraining to the folder corpus. We then input 2 to start retraining. After pre-processing, we can see the information about the new model in the txt file named model info with the date retrained. Information like the current model that is adopted, number of training corpus, R-squared score, and the equation to calculate the readability score are presented here. On the whole, we achieved the expectation of formulating a readability model in a scientific and automatic approach. It is hoped that our solutions could provide valuable insights for the insurance industry. Thank you for listening.